I'm Nitishas and welcome to the section of grade 10 CBSE physics class. Today we are looking at the chapter number 2, human eye and the colorful world. In this chapter, the main chapter is divided into 3 sections. I am dividing the main sections of the chapter into 3. For easy understanding, for easy studying, the main topics are divided into 3 sections. And first section is structure of human eye. First section is structure of human eye. And the second section is defects that cause due to human eye. Third section, the phenomenons are related to the vision or something which is related to light, like dispersion, atmospheric refraction, scattering, like the phenomenon. So mainly 3 sections are there in this chapter. First is structure of human eye, second defect that cause due to human eye, and third some phenomena related to light. These 3 sections are here in this chapter, and this is a simple chapter. If you study these 3 sections clearly, then you will be able to answer all the questions that are related to human eye and the colorful world. So moving to our first section, which is the structure of human eye. So in structure of human eye, we need to understand the structure and the parts and the functions of all the parts related to the human eye. Okay, the structure, parts and functions of the parts related to the human eye. This is our first section. So I already wrote a picture of human eye, structure of human eye in the board and marked all the parts related to the human eye. So this is a schematic representation of structure of our human eye. So I marked so many parts related to the human eye. Just look at the figure and starting from this portion, this is the cornea. This portion, this is the cornea. Next, this one. This portion is the pupil. This portion is the pupil. And the space between cornea and pupil. Look at the space between cornea and pupil. This space. This space is the aqueous humor. This space contains the aqueous humor. And this is our lens. This is our lens, eye lens. And this area is the blind spot. And this one is the optic nerve. And this complete area between this eye lens and the last portion of the eye, this complete area is the vitreous humor. Then this dark area, this like a screen, this dark area is the retina. And then these small muscles, both sides, these small muscles are the ciliary muscles. And here there is a dark region, this is the iris. So these are all the parts in the human eye. So we need to mention the functions of all the parts. Okay, this is the structure. Just look at the figure and identify which are the parts and mark where in the figure. Okay, we can start from cornea. Cornea is the transparent front portion of the eye. Cornea is the transparent front portion of the eye. This is a thin membrane. Cornea is a thin membrane. Light from the surroundings enter the eye through this transparent cornea. Through this transparent cornea. Okay. So cornea is a thin membrane. It is the transparent front portion of the eye. Light from the surroundings enters the eye through this transparent portion, through this transparent region. Next is pupil. Next is pupil. Okay. So pupil is a small hole in the middle of iris. Pupil is a small hole in the middle of iris. Light enters the eye and reaches the eye lens through this small hole. Light enters the eye through this small hole. So pupil is a small aperture or small hole in the middle of the iris. Light enters the eye and reaches the eye lens through this small hole. Next is iris. Next is iris. This iris controls the amount of light entering the eye by changing the size of the pupil. So what is the function of iris? This iris controls the amount of light entering the eye by changing the size of the pupil. Next is aqueous humor. So in the figure there is a space between cornea and eyelids. There is a space between cornea and eyelids, and the space between cornea and eyelids is filled by a fluid named aqueous humor. Humor means fluid. So aqueous humor is simply a fluid which fills the space between cornea and eyelids. Aqueous humor is a fluid which fills the space between eyelids and cornea. In between eyelids and cornea there is a space, and this space is filled by a fluid named as aqueous humor. Next is eyelids. Next is eyelids. So in our human eye, the lens is of convex type. In our human eye, the lens is of convex type. Okay. So human eye consists of convex lens. Human eye consists of convex lens. And this lens is made up of jelly-like material. This lens is made up of jelly-like material. And the curvature of this lens can be adjusted with the help of ciliary muscles. The curvature of this lens can be adjusted. Curvature can be adjusted. That means focal length can be varied. Focal length is not fixed. It can be varied with the help of ciliary muscles. With the help of ciliary muscles. So eyelens, in human eye we are having convex type eyelens. This is made up of jelly-like material, and the curvature of the lens can be varied or changed with the help of ciliary muscles. Next, ciliary muscles. These are muscles attached to both ends of eyelids. These are muscles which attached to the ends of eyelids, and when these muscles expands and contracts, when these muscles expands and contracts, due to the expansion and contraction of these muscles, curvature of the eyelids varies. So curvature of eyelids varied with the help of ciliary muscles. Next part is retina. In the human eye, image is formed on the retina. In the human eye, image is formed on the retina. It is a screen on the eye where image is formed. It is simply a screen on the eye where the image is formed. The image formed in the retina is real and inverted. It's an inverted image formed in the retina. Next is vitreous humor. There is a large space between eye lens and retina. There is a large space between eye lens and retina. This space is filled by a fluid called vitreous humor. So vitreous humor is a fluid which fills the space between eye lens and retina. Vitreous humor is a fluid which fills the space between eye lens and retina. Next is optic nerve. Next is optic nerve. So the main function of human eye is to see. That's the sense of vision. Human eye cannot identify or analyze what we are seeing. The function is just to see. Who analyzes what we are seeing? Our brain analyzes what we are seeing. When image is formed on the retina, this image should goes to the brain, and then brain analyzes and said to us, you are seeing this one, you are seeing that object, you are seeing that man. So brain analyzes what we are seeing. So the image formed on the retina should goes to brain. This image transmitted to brain through optic nerve in the form of electrical signals. Image cannot be sent to the brain as image. It can be transmitted in the form of electrical signals. So what is the function of optic nerve? Optic nerve carries image from retina to the brain in the form of electrical signals. We already said that retina is the screen where image is formed. And for image formation, retina contains two types of cells. They are rod cells and cone cells. Retina contains two types of cells, rod cells and cone cells. Last is blind spot. Blind spot is the region where no image is formed. That means rod cells and cone cells are absent in blind spot. Rod cells and cone cells are absent in blind spot. So there is no image formation in blind spot. No image is formed in the blind spot because rod cells and cone cells are absent in blind spot. These are all the parts related to human eye. Once more, we can go through the parts. First is cornea. Remember the points related to cornea. What is cornea? It is a thin membrane. First point. It is the transparent front portion of the eye. Second point. Light enters the eye through this transparent front portion, or light from the surroundings refracts to the inside of the eye. So 3 points related to cornea. Next is pupil. What is pupil? Pupil is the small hole in the middle of iris. First point, pupil is a small hole in the middle of iris. Second point, light enters the eye and reaches the eye lens through this pupil. Light enters the eye and reaches the eye lens through this pupil. Next is iris. So one more thing we can say about pupil is that it appears black. So 3 points related to pupil are: it is a small hole in the middle of iris. Light enters the eye and reaches eye lens through this pupil. It appears black. Next is iris. Iris controls the amount of light entering the eye. Iris controls the amount of light entering the eye. How iris controls the amount of light entering the eye? Simply by changing the size of pupil. So what is the function of iris? Just only 1 point. Iris controls the amount of light entering the eye by changing the size of pupil. Next is aqueous humor. Only 1 point. The space between cornea and eye lens is filled by a fluid called aqueous humor. So aqueous humor is a fluid which fills the space between cornea and eye lens. Just only 1 point. Next is eye lens. The points related to eye lens are: simply eye lens in human eye is convex type lens. Second point, it is made up of jelly-like material. Third point, the curvature of this lens can be adjusted with the help of ciliary muscles. Next part is ciliary muscles. These are muscles attached to eye lens. Due to the expansion and contraction of these muscles, curvature of eye lens can be varied. Due to the expansion and contraction of these ciliary muscles, curvature of eye lens can be varied. Next is retina. Retina is a screen on our eye where image is formed. So image is formed on the retina. First point. Second point, retina contains rod cells and cone cells. Next is vitreous humor. The space between eye lens and retina is filled by a fluid called vitreous humor. Next is optic nerve. So the function of eye is to see, the sense of vision. So human eye can only see the object, cannot analyze what we are seeing. The function to analyze what we are seeing is brain. So the image formed in the eye must reaches our brain to analyze what we are seeing. So image formed on the retina is transmitted to the brain through optic nerve, but it cannot be as sent in the form of image. It can be transmitted in the form of electrical signals. So function of optic nerve, it carries image from retina to the brain in the form of electrical signals. Last one is blind spot. It is a spot, it is a region in retina where rod cells and cone cells are absent, so no image is formed here. This is a region in retina where rod cells and cone cells are absent, so no image is formed here. This is the whole structure of human eye. This is the whole structure of human eye. Once more, listen carefully to the figure. Identify the parts which are marked and recollect what are the functions of these parts that I explained right now. Okay, that's all about the structure of our human eye. Clear? The next topic is power of accommodation of human eye. Next topic that we are going to discuss is power of accommodation of human eye. Power of accommodation of human eye. What do you mean by power of accommodation? It is simply the ability of eye lens to change the focal length. The ability of eye lens to change the focal length with the help of ciliary muscle. That's simply power of accommodation. The ability of eye lens to change the focal length is called power of accommodation of eye. Okay. Then the near point of human eye, the near point of human eye is 25 centimeter. Near point of human eye is 25 centimeter. And the far point of human eye is infinity. Far point of human eye is infinity. So we can see clearly from 25 centimeter to infinity with normal human eye. That means the eye which does not having any defects. So with a normal human eye, the range of vision is from 25 centimeter to infinity. That means the near point is 25 centimeter and far point is infinity. So what do you mean by power of accommodation? The ability of eye lens to change the focal length with the help of ciliary muscles is known as power of accommodation of eye lens. Near point of human eye is 25 centimeter and far point is infinity. Okay. Next, we are going to discuss about defects of human eye. Next, we are going to discuss about defects of human eye. So, we need to discuss about first one defect is color blindness. First defect is color blindness. The next defect we need to discuss is myopia or short-sightedness. Myopia or short-sightedness. Next is hypermetropia. Next is hypermetropia or long-sightedness. The next one is presbyopia. Next is presbyopia. And the fifth one, astigmatism. Fifth one is astigmatism. And the last is cataract. Last is cataract. So we need to discuss these 6 defects that can harm human eye. So which are the defects that causes human eye? Color blindness, myopia, hypermetropia, presbyopia, astigmatism and cataract. So moving to the first one. First is color blindness. We can see different colors because in our retina we are having rod cells and cone cells. In rod cells and cone cells are responsible for seeing colors. Cone cells are responsible for seeing colors. So for different colors, different cone cells are responsible. So due to genetic disorder, if someone having some absence in specific cone cells, then they are not able to see that colors responsible for that cone cells. Such defect is known as color blindness. So we can say that color blindness is a defect in human eye due to which some persons cannot see some specific colors due to the absence of cone cells, and this happens due to genetic disorder. So what is color blindness? It is a defect in human eye due to which some persons cannot see some specific colors. What is the reason behind this? It is due to the absence of cone cells. It is due to the absence of cone cells that are responsible for seeing colors. How it happens? It happens due to genetic disorder. It happens due to genetic disorder. So remember 3 points related to color blindness. Some persons are not able to see some specific colors. That defect is known as color blindness. And the reason for color blindness is the absence of some specific cone cells. How it happens? It happens due to genetic disorder. It happens due to genetic disorder. That's color blindness. Next, we are moving to myopia. This myopia is also known as short-sightedness. This myopia is also known as short-sightedness. From the name, it is clear that short-sightedness simply means this is a defect of human eye due to which a person can see nearby objects clearly but cannot see far objects clearly. That's what called myopia or short-sightedness. That's what called myopia or short-sightedness. So what is myopia? It is a defect in human eye due to which a person can see nearby objects clearly but cannot see far objects clearly. This defect is known as myopia or short-sightedness. This defect is known as myopia or short-sightedness. What is the reason behind this myopia or short-sightedness? There are two reasons for myopia or short-sightedness. First is excessive curvature of cornea. First reason for myopia is excessive curvature of cornea. Excessive curvature of cornea. Second reason is elongation of eyeball. Second reason is elongation of eyeball. Next point we need to discuss is how this defect can be corrected. How this defect can be corrected. This defect can be corrected by using a spectacles having concave lens. By using concave lens of suitable power, we can rectify or correct this defect. Points are clear? Last, we need to draw the figure of a myopic eye and its correction. We need to draw a figure of myopic eye and its correction. So I am going to draw the figure of myopic eye and its correction. So for a myopic eye, we know that for a normal vision, image should be formed on the retina. Image should be formed on the retina. So in case of a person having myopia, the image is formed in front of retina. Image is formed in front of retina. So how this can be correct? We need to shift the position from here to the retina. So for shifting the position towards backward, we need a diverging lens. Which is diverging lens? It is a concave lens. So for correcting myopia, we can use a concave lens. Now we need to draw the correction of myopia. So this is the correction of myopia. So how myopia can be corrected? By using a concave lens of suitable power, we can correct myopia. So what all things we have discussed? We are discussing about myopia. Myopia is a defect in human eye due to which a person can see nearby objects clearly but cannot see far objects clearly. What is the reason behind this myopia? First one is excessive curvature of cornea. Second one is elongation of eyeball. Second one is elongation of eyeball. Then how it can be corrected? By using a concave lens of suitable power, myopia can be corrected. This is the figure of a myopic eye where image is formed in front of the retina. This is the correction. Now image is formed on the retina. Clear? So we completed myopia. The next defect that caused it to human eye is hypermetropia. Next defect that caused to human eye is hypermetropia. Otherwise, it can be called as long-sightedness. Hypermetropia or long-sightedness. Next is hypermetropia or long-sightedness. Hypermetropia or long-sightedness. From the name itself, it is clear that hypermetropia is a defect due to which a person can see far objects clearly but cannot see nearby objects clearly. So what is hypermetropia? Hypermetropia is a defect due to which a person can see far objects clearly but cannot see nearby objects clearly. What is the reason behind this hypermetropia? There are two reasons for hypermetropia. First is decrease in power of eye lens. Next is shortening of eyeball. So two reasons behind hypermetropia is that decrease in power of eye lens is one reason, and next is shortening of eyeball. Then how this hypermetropia can be corrected? This hypermetropia can be corrected by using a convex lens of suitable power. This hypermetropia can be corrected by using a convex lens of suitable power. So now we need to draw the figure for correction. So first I am drawing a figure of hypermetropic eye. Now look, this is a hypermetropic eye. For a normal eye, for normal vision, we know that the image should be formed on the retina. But look here, here the image is formed behind the retina. Here the image is formed behind the retina. So we need to shift this position to the forward direction and image should be formed on the retina. For moving in the forward direction, we need a converging lens, that is a convex lens. So we can use a convex lens of suitable power for correcting this hypermetropia. So the image for correction. This is the correction for hypermetropia. Now look, image is formed on the retina. So what all things we have discussed about hypermetropia? Hypermetropia is a defect in human eye due to which a person can see far objects clearly but cannot see nearby objects clearly. What are the reasons behind hypermetropia? The reasons behind hypermetropia are, first one is decrease in power of focal length. Sorry, decrease in power of eye lens. Decrease in power means increase in focal length. Either in any way you can say either decrease in power or increase in focal length. You know that power is the reciprocal of focal length. So focal length increasing means power decreasing. Power increasing means focal length decreasing. So first reason is decrease in power of focal length. Second is shortening of eyeball. How it can be corrected? It can be corrected by using a convex lens of suitable power. It can be corrected by using a convex lens of suitable power. This is the image of hypermetropic eye and this is the figure for correction. Okay. Now the next defect we need to discuss is presbyopia. Next defect is presbyopia. This presbyopia is a defect in human eye, happens due to aging. This is a defect in human eye that happens due to aging. What are the reasons behind this presbyopia? You all know that due to aging, our muscles are weakened. We are having so many health issues. So, due to aging, our eye lens decreases its flexibility to change its focal length. So, simply first reason is decrease in flexibility of eye lens. First reason for presbyopia is decrease in flexibility of eye lens. And how eye lens changes the focal length? The eye lens are changing its curvature or focal length with the help of ciliary muscles. When people age, these muscles become gradually weakened and so eye lens are not able to change its focal length. So first reason we can say that decrease in flexibility of eye lens, and second is gradual weakening of ciliary muscles. Second reason is gradual weakening of ciliary muscles. So what is presbyopia? It is a defect in human eye that happens due to aging. It is a defect in human eye that happens due to aging. What are the reasons behind presbyopia? Decrease in the flexibility of eye lens, gradual weakening of ciliary muscles. So if you are having a question in your exam such that a person affecting both myopia and hypermetropia. What's the condition is called? A person affecting both myopia and hypermetropia. So a person having both myopia and hypermetropia. So he cannot see nearby objects clearly. He cannot see far objects clearly. What's the condition is known as? If a question asked like this, then the condition is also known as presbyopia, and that condition is also known as presbyopia. And it can be corrected by using bifocal lens. Can be corrected by using bifocal lens. You know that for myopia we need to use concave. For hypermetropia we need to use convex. So if a person having both, what we do? We have to use a bifocal lens. We have to use a bifocal lens. So presbyopia is a defect, happens due to aging. The reason behind presbyopia are, first one is decrease in flexibility of eye lens. Second one is gradual weakening of ciliary muscles. Okay. If a person affecting or suffering from both myopia and hypermetropia, then the condition is also known as presbyopia, and this can be corrected by using bifocal lens of suitable power. So that's all about presbyopia. Next defect is astigmatism. Next defect is astigmatism. Astigmatism is a defect in human eye due to which a person cannot see simultaneously both horizontal and vertical lines. If a person cannot see simultaneously vertical and horizontal lines, then he is suffering from astigmatism. So simply we can say that astigmatism is a defect in human eye due to which a person cannot see simultaneously both vertical and horizontal lines. That's astigmatism. Next is cataract. Next is cataract. Cataract is a defect in human eye that happens due to growth of membrane over eye lens. Due to this membrane growth, the eye lens become hazy or even opaque. You know that if it is opaque, then light does not enter into the eye. So we cannot see anything. So due to this membrane growth, we decreases the vision, or it may cause complete loss of vision. And this can be corrected only by surgery. This can be corrected only by surgery. So what is cataract? Due to membrane growth over eye lens, our eye lens become hazy or even opaque. This condition or this defect is known as cataract. This may lead to loss of vision or decrease in vision. And this can be corrected only by surgery. This can be corrected only by surgery. Okay, this is cataract. So when you are having questions like explain about cataract or what is cataract, you can explain like this: due to membrane growth over eye lens, our eye lens become hazy or even opaque. That leads to decrease in vision or complete loss of vision. This defect is known as cataract, and it can be corrected only by surgery. Clear? These are all the defects that can cause to the human eye. Which are the defects? Color blindness, myopia, hypermetropia, presbyopia, astigmatism, and cataract. These are all the defects that can cause to our human eye. So out of 3 sections in this chapter, we have completed 2 main sections: structure of human eye and defects that causes the human eye. Okay, and the 3rd section comprises of some phenomena related to light and some natural phenomena like blue color of sky, formation of rainbow, color of sunrise and sunset, twinkling of stars. So in this section, we explain all these phenomena. And this is the last section of this chapter. So in the 3 sections, we completed 2, and this is the last section. Okay. So first, we are going to discuss about dispersion. What do you mean by dispersion? Dispersion is a phenomenon in which white light is splitted up into its constituent colors. So when we are considering sunlight, if it is splitted into its constituent colors, how many colors sunlight have or white light has? White light or sunlight consists of 7 colors, that is violet, indigo, blue, green, yellow, orange and red. 7 colors. When this white light is splitted into 7 colors, that phenomenon is known as dispersion. So we can simply say that dispersion is the phenomenon in which splitting up of white light or visible light or sunlight into its constituent colors. How this can be done? When a white light is passed through a glass prism, when white light is passed through a glass prism, inside the prism dispersion happens. Inside the prism dispersion happens, and this white light is splitted up into 7 colors, and 7 colors comes out of the prism. 7 colors comes out of the prism. So red, blue, green, yellow, orange, red. This phenomenon is known as dispersion. This phenomenon is known as dispersion. So what is dispersion? Splitting up of visible light into its constituent colors is known as dispersion. When white light is passed through a glass prism, inside the glass prism dispersion happens and 7 color comes out of the prism. This is what we call dispersion. Now we need to discuss about a recombination. We need to discuss about recombination. So when the same white light is passed through a prism and I am placing an inverted prism next to the prism, which dispersion happens. So what happens in the first prism? In the first prism, dispersion happens and 7 color comes out of the prism. Dispersion happens and 7 color comes out of the prism. And it enters the inverted prism, and inside the inverted prism, these 7 colors combines. These 7 colors combines and comes out as white light. These 7 colors combines and comes out as white light. So what is recombination? Constituent colors combines to give the white light. That means these 7 colors combines to give white light. This phenomenon is recombination. So how recombination happens? When white light is passed through a prism, dispersion happens and it is splitted up into 7 colors. When these 7 colors are passed again through an inverted prism, inside the inverted prism, these 7 colors combines and comes out as white light. This is what called recombination. So in the first prism, dispersion happens, and in the second inverted prism, recombination happens. So in the first prism, dispersion happens, and in the second inverted prism, recombination happens. The next topic we need to discuss is monochromatic light and polychromatic light. Monochromatic light means light consisting of only single color. Light comprising of single color or single wavelength is known as monochromatic light. But light consisting of more than one color or more than one wavelength is known as polychromatic light. Sodium light is an example for monochromatic light. White light is an example for polychromatic light. So what is the difference between monochromatic and polychromatic light? Monochromatic light consists of only one color or only one wavelength. Example, sodium light. Polychromatic light means it consists of more than one color or more than one wavelength. Example, white color. Next phenomenon we are going to discuss is atmospheric refraction. You all studied refraction in the previous chapter, that when a ray of light passes from one medium to another, the path of the light or the light ray bends, and that bending is known as refraction. The phenomenon of bending of light when it passes through one medium to another. That phenomenon is known as refraction. But here it is atmospheric refraction. Simply, refraction caused by the atmosphere of Earth is known as atmospheric refraction. That means when a ray of light is passed through the atmosphere of Earth, the path of light simply bends. It is due to the atmospheric layers having different density. When the light ray passes through these layers having different density, it acts as different medium and the light ray bends. So that phenomenon is known as atmospheric refraction. Simply we can say that the refraction caused due to the atmosphere of Earth is known as atmospheric refraction. Clear? Any doubt? Next topic we are going to discuss is scattering. Next is scattering. Simply we can say that when a light ray or when light meet on obstacles, it gets spread around the obstacle, and that phenomenon is scattering. So we can say that spreading of light around obstacles is simply known as scattering. Or otherwise we can say that light strikes on surfaces of particles and the path of light gets deviated around the obstacles or gets spreads around the obstacles, and that phenomenon is known as scattering. And we are having a relation between scattering and wavelength. Those colors having greater wavelength scatters less. Those colors having lesser wavelength scatters more. So scattering and wavelength are interconnected, that those colors having greater wavelength. In 7 colors, that is violet, indigo, blue, green, yellow, orange and red, simply VIBGYOR. The 7 colors in rainbow. In these 7 colors, red has the highest wavelength and violet has the least, or simply we can say that violet, indigo, blue, these has the least wavelength and these has the highest wavelength. So red having highest wavelength scatters very less. Violet, indigo, blue having least wavelength scatters more. This is the relation between scattering and wavelength. Next topic we are going to discuss is formation of rainbow. Formation of rainbow. How rainbow is formed. You all know that rainbow is formed in the sky after raining. Not in noon time. After raining, we can see sometimes rainbow. How this rainbow is formed. After raining, atmosphere consists of lots and lots of water droplets. After raining, atmosphere consists of lots and lots water droplets. These water droplets simply act as prisms. These water droplets simply act as prisms. So we know that when light ray passes through the prism, dispersion happens. So after raining, when sunlight passes through the atmosphere, these sunlight enters the water droplet. So from air, it is passing through water. So it gets first refracted. Okay. Then inside the water droplet, it gets continuously reflected. And also with the reflection inside the water droplet, dispersion happens, and the sunlight is split up into 7 colors. Dispersion happens and the sunlight is split up into 7 colors. And these 7 colors refracts again and comes out of the prism. That means here prism is water droplet. So 7 colors comes out of the water droplet. These 7 colors is seen as a band or spectrum, and that band of colors or spectrum of colors is simply known as rainbow. So how rainbow is formed? After raining, atmosphere consists of lots of water droplets. When sunlight passes through the atmosphere and enters the water droplet, first refracts into the water droplets. Inside the droplet, it gets continuously reflected and dispersed to split into 7 colors. It again refracts out of the water droplets. having 7 colors: red, the violet, indigo, blue, green, yellow, orange, and red. This band of colors or this spectrum of colors is seen as rainbow. Is seen as rainbow. That's how rainbow is formed. Clear formation of rainbow. Simply you can write in step by step. After raining, atmosphere consists of lots and lots water droplets. These water droplets act as small prisms. Sunlight refracts into the water droplets. Then inside the droplet it gets continuously reflected. Along with the reflection, dispersion happens and this sunlight is split into 7 colors. Then again refracts out of the water droplet and 7 color is coming out of the water droplet. From lots and lots of water droplets like this, 7 colors are coming out, and this band of colors is seen as rainbow. This band of colors is seen as rainbow. That is the formation of rainbow. Now we need to discuss about color of sunrise and sunset. Now we need to discuss about color of sunrise and sunset. You all know that during sunrise and sunset, sun is seen as a reddish color or an yellowish orange color or an orange reddish color, like something similar to a red color. How this happens, that we are going to explain color of sunrise and sunset. So when we are considering Earth, consider this as our Earth. This is Earth. Actual sunrise happens when it is above the horizon. Actual sunrise happens when it is above the horizon. Consider this as the horizon. Actual sunrise happens when it is above the horizon, but when it is below the horizon, this is the sun. When it is below the horizon, sunlight from the sun reaches Earth, and when this sunlight passes through the atmosphere of Earth, atmospheric refraction happens. When the sunlight passes through the atmosphere of the Earth, atmospheric refraction happens. Due to this atmospheric refraction, part of the light bends and reaches observer's eyes. So when we are looking from the Earth, we seen sun at an elevated position. We seen sun at an elevated position, but this is not the actual position. It is the apparent position. This is not the actual position. It is the apparent position. So actually sun is here, but we are seeing here. So this is the position of the sun. And due to this position, we are seeing sun as early. That means we are seeing sun 2 minutes early. I am coming to the color of sunrise and sunset. Before the color of sunrise and sunset, I am explaining about the actual daytime increasing by 4 minutes. That is advanced sunrise and delayed sunset. After explaining this, we can move through color of sunrise and sunset. So actual sun's position is here, but we are seeing it here. That means we are seeing sun 2 minutes before the actual sunrise. In the evening time also, when the sun sets below the horizon, sunlight comes from the sun and reaches the earth, atmospheric refraction happens, and we are seeing sun above the actual position. It is an apparent position. That means after sunset happens, we can see 2 minutes more the sun. So 2 minutes in the morning and 2 minutes in the evening. So we are getting total 4 minutes extra in the daytime. This is what called advanced sunrise and delayed sunset. This is what called advanced sunrise and delayed sunset. After this, we can explain color of sunrise and sunset. So when the color of sunrise and sunset, I am just explaining before the advanced sunrise and delayed sunset. So what do you mean by advanced sunrise or delayed sunset? Otherwise, how we are getting 4 minutes extra in daytime? So actual sunrise happens when the sun is above the horizon. But when it is below the horizon, sunlight from the sun reaches the earth and it causes atmospheric refraction and reaches the observer's eye. When we are looking at the sun, we see the sun in an apparent position. So we are seeing sun 2 minutes early before sunrise. In the evening time also, after setting, we are seeing it again 2 minutes. So morning 2 minutes early we are seeing, after setting in the evening we are again 2 minutes seeing the sun. So 2 plus 2, 4 minutes we are getting extra in the daytime. This happens due to the atmospheric refraction. This happens due to the atmospheric refraction. Now we can move to through the topic color of sunrise and sunset. The actual sunrise and sunset happens in the horizon. Actual sunrise and sunset happens in the horizon. So from the horizon, sunlight needs to travel large distances to reach the earth. So from the horizon, sunlight needs to travel large distances to reach the earth. When the sunlight travels large distances, colors having least wavelength scatters more and it gets lost. So in 7 colors, that is violet, indigo, blue, green, yellow, orange and red. So violet, indigo, blue, green, yellow, orange and red. Colors having least wavelength scatters more and lost. So when the sunlight from the horizon travels large distance at first, violet scatters completely and lost. Then indigo scatters completely lost. Blue scatters completely lost. Green scatters completely lost. At last, colors having highest wavelength reaches the earth and in that color we are seeing the sun. At last, colors having highest wavelength scatters less and reaches earth and in that color we are seeing the sun. So in the sunrise and sunset we are seeing the sun in a reddish color. In a reddish color. That's the color of sunrise and sunset. Clear? Now moving to the next topic. Next is twinkling of stars. We all see in the night time outside when looking at the sky, the stars get twinkled or blinking of stars. Actually, stars are not twinkling. They are giving out of light are the same way sun gives us light. The stars are not twinkling. Then what is the reason why we are seeing it as twinkling? Because we know that stars are at a large distance from earth. Stars are at large distance from earth. So these stars giving light reaches the earth, and when this light passing through the earth, happening atmospheric refraction, causes atmospheric refraction and reach observer's eye. So when we are seeing the stars, we are seeing it an apparent position, not in actual position. This is the apparent position, not in actual position. And it is at a very large distance from the earth. We see it as minute objects. And this happens again and again. The stars are continuously giving out of light, reaches the earth, and in the earth it causes atmospheric refraction, path of the light bends and we see it in the apparent position. So the apparent position changes continuously. These positional change may appear as twinkling of light. These positional change may appear as twinkling of light. Actually, it is not twinkling. So these are at a large distance from the Earth, we see it as minute objects. So these minute objects changing the apparent position, seeing as twinkling of stars, seeing as twinkling of stars. So how we can explain the phenomenon twinkling of stars? Stars are at a large distance from Earth. They are giving out of light. This light travels large distance and reaches Earth. When traveling through Earth's atmosphere, it causes atmospheric refraction and the light reaches observer's eye. So when we are looking at the stars, we are not seeing the stars in the actual position, but we are seeing it in an apparent position, which is slightly above the actual position. So these stars are continuously giving out of light, and the apparent position may continuously changing. This positional change may appear as twinkling of light. That's the twinkling of stars. Next topic is color of sky. You all know that this color of sky appears to be blue. Color of sky appears to be blue. This is not actually blue. We say it as sky blue. That may be a mixture of violet, indigo blue. That may be a mixture of colors having least wavelength. So when you are having questions in the exam such that why the color of sky is blue, it is saying that blue. So simply we can say that blue color has least wavelength. From violet, indigo blue, they are having least wavelength. The least wavelength colors get scattered more. The least wavelength colors get scattered more and spreads all over the sky. And spreads all over the sky. That's why we are seeing it as in blue color. That's why we are seeing it as in blue color. So what is the color of reason behind color of sky? It is simply scattering. What is the reason behind color of sky? It is simply because of scattering. Least colored, least wavelength colored scatters more and scatters all over the spreads all over the sky. That's why we see it as in blue color. That's why we see it as in blue color. Next, we are seeing the sky in blue color, but astronauts who are traveling through space see the sky in a dark color, not in blue color. Why? Because in space there is no atmosphere. Because in space there is no atmosphere. So without atmosphere, scattering does not happen. Scattering does not happen. So if there is no scattering, no color will be seen. If there is no scattering, no color will be seen. Absence of colors. So it is seen as dark. So that's a question. Why astronauts see sky as dark? Because in space there is no atmosphere, no scattering happens. So it is seen as black. The next question. In danger signal lights, red color is chosen. Why? In danger signal lights, red color is used. Why? Because we know that red color has greatest wavelength. Red color has greatest wavelength. So this color scatters less. That means this red color can travel more distance. Red color can travel more distance. That's why in danger signal lights, we are using red color because we can see the color from a large distance. Okay. Next, the last topic of the chapter is Tyndall effect. The last topic of the chapter is Tyndall effect. What do you mean by Tyndall effect? That this effect you have studied in the previous class. That means the 9th grade chemistry. In 9th grade chemistry, you are having this topic Tyndall effect. Tyndall effect means scattering of light by colloidal particles. When light is passed through colloidal particles, it gets scattered from these colloidal particles. So when we are taking a colloidal solution, when we are taking colloid and light is passed through these colloids, it gets scattered through or it gets scattered from that colloidal particles. That colloidal particles. So we can simply say that scattering of light by colloidal particles is known as Tyndall effect. Scattering of light by colloidal particles is known as Tyndall effect. That's all in this chapter. So what we have studied in this chapter? First section, structure of human eye. In the structure of human eye, in the picture, we have labeled all the parts. Just recollect what is in the picture and where the parts are labeled. Retina, cornea, iris, pupil, eyelens, ciliary muscles, blind spot, vitreous humor, aqueous humor, and blind spot. These are the all parts of the human eye and all the functions are discussed. Then what are the defects causing to human eye? Color blindness, myopia, hypermetropia, presbyopia, astigmatism, and cataract. These are the defects that causes harm to the human eye. Then the last section is some phenomena related to the light. Which are they? We discussed about dispersion, recombination, monochromatic light, polychromatic light, atmospheric refraction, scattering. Then some general question. Color of sunrise and sunset, advanced sunrise and sunset, formation of rainbow, blue color of the sky, reason for behind blue color of sky, twinkling of stars, why astronauts see sky as dark, why in danger signal lights red color is used. Then we are getting 4 minutes extra in daytime. What's the reason behind this? Then the last topic, Tyndall effect. These are all the topics that we have discussed in this chapter. Only you are getting questions from this topic. You need to study only these topics. You will get full marks from this chapter. That means if you are completing this much of topic that I have discussed, then you will surely score full marks. Okay? I am Nidishas and thank you for joining me in this section. Let us meet with another section in another day. So I am signing off. Thank you.